Okay, let's start at the beginning. If we put cos 60 into our calculator, we are going to get a half as an answer. Cos 60 is a half. Sine of 180 degrees should be 0. We should get 0 over here. And who can tell me, what did they get for tan 270? What did we get for tan 270 degrees? Anyone get something? Correct. Okay. So most of you guys are saying undefined, and that's absolutely true. It is undefined. Khulani, I just want to read your message quickly just to make sure I don't miss it. 5 and 6, is it not from the degree chart whereby you solve without using a calculator? Yes, correct. So there are special angles, and we will get to learning special angles, Khulani, just not quite yet. Good. This is undefined, and I'm going to explain why it's undefined as we go. We're going to be able to see it on a graph, but this isn't just tan 270. Even if you type in tan of 90 degrees into your calculator, it should give you undefined. It's an undefined function. We're going to explain why it's undefined when we get to that part of the maths. But for the meantime, we're just going to learn that tan 90 and tan 270 are undefined. All right, let's look at this one over here. We know tan theta is equal to 1. They've given us the ratio. They want the angle. So we must click shift. So arctan of 1 is equal to 45 degrees. Okay, don't forget the degrees, guys. Okay, sine theta is equal to root 2 over 2. I know that theta is going to equal arc sine of root 2 over 2. And this should give me 45 degrees as well. Okay, this should give me 45 degrees. Now, cos of theta is equal to root 3 over 2. That means I'm looking for theta. So that theta is going to be arc cos of root 3 over 2. Let me see if I can do this in my head. 1, 2. Oh, I'm lying. 1, 2, root 3. Okay, and that makes that 60. So this should be 30 degrees. If I'm not mistaken, this should be 30 degrees. Okay, I'm trying my best not to use a calculator, but okay, these are the answers we should be getting. And somebody did mention that these are actually called special angles. Absolutely, they are. We're going to get to the part where we learn about special angles. All right. So I'm just going to say a big shout out to everybody today, because today we actually have 2 of our classes put together. We've got the grade 10 foundations and the grade 10 standard class together. So welcome to, I'm hoping I'm getting this right. Vukosi, welcome Tandaleti, welcome Sia, welcome Desmarie. It's great to have you guys with us in today's lesson. We'll see if anybody else from our other class actually joins us. So everybody else is 10S, welcome to today's lesson. All right, today we're going to be learning a little bit more about angles. We're going to be finding the angles, well, sides and angles, but we're going to be going through the rules a little bit more. I want to see if you guys remember. There are exactly 3 rules that we need to follow. Who can remind me? I know, Narisha, all of these people, so lazy. They're probably sleeping. All right, what is rule number 1? Thank you, Khulani. You're still DMing me, but you're absolutely giving me the correct answers. Good. Step number 1 is always to label. Hi, Vikanyo. There's another one. Yes, Vikanyo also from 10F. Hi, Vikanyo. Welcome. All right, good. Step number 1 is to label. What is step number 2? Who can remind me? Step number 2? Good. Well, not what we exactly. Okay, good. So I'm going to say it's what we have. Okay, I'm just going to call it the have versus want. Okay. And then for step number 3, what do we need to put together in order to solve for this? A what? Ah, Desmarie, right on time, beautifully said. Good. We need to form an equation. And we know that our equation is going to be informed by the SOHCAHTOA part of it. All right. And yeah, most of it is just easy breezy. So can I leave you guys with these 4 questions? Okay, I'm going to give you guys 5 minutes to do these 4 questions. When you are ready, pop me your favorite emoji in the chat. I am in a really good mood today, so I'm going to put the party emoji. My friends came to visit for the long weekend, so I was having a great time. All right. Okay, peeps. I'm going to give you guys 4 minutes. I'm going to grab a glass of water, and I will be right back. Okay, well, 5 minutes, sorry, not 4, 5. Pulani and Bikanyo are done. Pulani, ever the robot, always done way before everyone else. Well done. Well done, Bikanyo. I see you. Ugosi is also done. We'll just give everybody else some time to catch up. We've got 2 minutes to go, guys. One more minute, guys. All right, peeps, let's have a look at the answers. Okay, I think most of us should be done by now. All right. Okay, so in the first question over here, question 9, we're first going to have to label. That's what we always do. So we're going to start with the 68 degrees. I know that on this side over here, right close to it, that's my adjacent side. That 15 over there is my opposite side, and the x over there is my hypotenuse. Now, that is labeling. That's step number 1. Now we need to look at what we have versus what we want. All right, so I know that I have been given the angle 68 degrees and I've been given the opposite side. And I want x, which is the hypotenuse side. Somebody tell me in the chat, when I write my equation, which one am I going to use, sine, cos, or tan? Beautiful, Trulani. I didn't even finish my sentence, but yeah, good, always on point. Good, we're going to use sine. So we're going to write down the equation. Sine theta is equal to opposite over hypotenuse. Good one, Emmanuel. Excellent. Good, and then we're just going to substitute in, right? We're going to take sine of 68 degrees is equal to the opposite, which is 15 over the hypotenuse, which is x. Then I know that I must cross multiply in order to get that x out of the denominator. So we're going to cross multiply. We can put this over 1 and cross multiply. So what I'm then going to get is x times sine 68 degrees is equal to 1 times 15 will give us 15. But I want x on its own. So what I'm going to have to do here is I'm going to have to divide both sides by sine 68. Right? And those two will cancel. Therefore, x is equal to 15 over sine 68, which is equal to 16,18. Thank you, Emmanuel, as always. Excellent, good work. All right, that is number 9. Let's look at number 10 quickly. I'm going to move our SOHCAHTOA down a little bit. All right, so over here, again, I'm going to label this one right next to me, that one, that is my adjacent side. That one over there, that is the opposite. And this side over here is the hypotenuse. Good. I've labeled, what do I have? I have a 35-degree angle. And I also have my adjacent side. What do I want? I want x, which is my opposite side. Right. Now, I know that I've got adjacent and opposite. So when I write my equation, what am I using? Good. I'm using tan. Excellent. So I know my equation must go tan theta is equal to opposite over adjacent. It's the TOA, O over A. Right. So I'm going to get tan of 35 degrees is equal to opposite, which is x, over adjacent, which is 10. All right, and I'm going to put this over 1, and we're going to cross multiply. 10 will go that way, and 1 will go that way. So I'm going to get 1 times x is equal to x, and then 10 times tan 35 is just tan, 10 times tan, 35 degrees. And we can punch that into our calculator. What am I getting as an answer, peeps? 10 tan 35 is equal to exactly 7. Good. It's 100%. Okay. Let's look at question 11. Okay. Question 11, again, I always start with labeling. Right. I know that this side over here is my adjacent, 16 over there is my opposite, and x over here is my hypotenuse. All right. Now I'm going to look at what I have versus what I want. Okay, I have 33 degrees and I have the opposite side and I want the hypotenuse. So I know SOHCAHTOA or TOA, I'm going to use sine here. Yes, beautiful. Good. Sine theta is equal to opposite over hypotenuse. And then we're just going to substitute. I'm going to get sine of 33 degrees is equal to the opposite, which is 16 over the hypotenuse, which is x. And then as always, I'm going to put this over 1, and then I'm going to cross multiply. Multiply that one that way, multiply that way. So I'm going to end up with x sine 33 is equal to 1 times 16 is 16. And then we're going to divide both sides by sine 33 to get x on its own. Somebody pop an answer in the chat for me. What is the answer that I would get here? Therefore, x is equal to, what do we get? Thank you, Emmanuel, efficient as always. over sine 33. Beautiful. Good. 29,38. Excellent. All right, let's look at question 12. Okay, and again, guys, I don't think we're reinventing the wheel. We're doing the same thing over and over again. We're going to label. This is the adjacent side. That over there is the opposite side. 17 over here is the hypotenuse. Oh, didn't write that one quite right. There we go. Hypotenuse. Right, and then I'm going to look at what I have versus what I want. What I have is 45 degrees, and I have the hypotenuse. And what I want is the x, which is the adjacent side. Thank you, Kulani. I haven't even asked the question yet. And Kulani's already written cos in the chat. Thank you, Kulani. Absolutely, we're going to use cos. So we're going to go cos of theta is equal to adjacent over hypotenuse. All right, so let's substitute. Cos of 45 degrees is equal to adjacent, which is x, over hypotenuse, which is 17. All right, then again, we're going to put this over 1, and we're going to cross multiply. Cross multiply. I'm going to get 1 times x will give me x, and then 17 times cos 45. Which I'm thinking is something like 17 root 2 over 2, but I cannot be 100% sure. What do we get here, guys? Cos 45, because I know cos 45, yeah, 100% on point. 17 root 2 over 2. If we click SD, it should give us 12,02, or approximately 12,02. All right, give me a mark out of 4. 1, 2, 3, 4. How did we do out of 4, peeps? Okay, I'm seeing a few 3s. Vukosi says 3. I'm seeing 4. For those of us who got 3, are we okay with where we didn't quite get it? Because I do need us to understand this part. This is the fundamentals of trigonometry. So we need to make sure. A teeny little mistake, it's okay. That's okay. Ziketelo, hi, my darling. It's been a while. I haven't heard from you. Hello, Ziketelo. Welcome. Silly mistakes. All right, we're not making any more silly mistakes. By the way, this is the place to make the mistakes, not during the lesson, not during a test or an exam. Okay, during this lesson is where we make mistakes and we learn from them. All right, okay, let's get into the meat of today's lesson, because what we're actually going to be doing today is we're going to be finding angles. And we know when we have to find angles, what do we need to do? What are we going to do in order to find angles? We must what? Come on. Before we label. Before we label, we already know if we're looking for an angle, we must shift angle. Guys, I told you I'm going to make a trend. I swear. I'm going to make it a whole thing. I'm going to make it a whole thing. Thank you, Vukos. Yes, we must shift angle. Thank you. All right. Good. So we know we're going to click shift. Now, they haven't given us enough information for us to go off of, but we're always going to start exactly where you said, Princess. We're going to start by labeling. The 3 steps do not change, guys. We're still going to do... Thank you, Sia. Okay, question 1. Step 1, step 2, step 3. None of it is going to change. So you're absolutely correct, Princess. Step 1 is to label. Step 2 is have versus want. And step 3 is to put an equation together. It's just that our equation is just going to take us a little bit longer to get where we need to go. All right, so here's what we're going to do. We're going to start by labeling. I know that this is the angle. The angle is what I want. So I know that this side over here is my adjacent side. The 13 over there is my opposite side. And that over there is my hypotenuse. Now, I know that I want the angle, but we still need to look at what we have versus what we want. What do I have? I've got the opposite side and I've got the adjacent side. What do I want? I want the angle. We can call the angle theta, right? So I already know that I'm going to have to click shift. Thank you, hashtag shift angle. I love it. Okay, so if we look at SOHCAHTOA, I know that I've got opposite and adjacent. Thank you, Kulani. We're going to use tan. So I'm going to do this. I'm going to go tan of theta is equal to opposite over adjacent. Now we have to substitute, but we don't have our angle. So we're going to leave the angle part out. So we're going to go tan of theta is equal to the opposite, which is 13 over adjacent, which is 21. But because I want the angle, I know that I need to take it an extra step further. Correct, Emmanuel. Arctan, absolutely. So I'm going to go theta is equal to arctan of 13 over 21. And that is equal to what? Okay, we're going to take arctan of 13 over 21, close brackets, and the answer we should get here is 31,76. Oh my gosh. Narisha, there are many jobs that don't require us to use shift angle. I can't believe you're rejecting my TikTok trend. It's okay though, it's fine. Yes, we could say that. We could say that. We could say it's to the power of -1. But like what it technically is how to find the angle, because the arc actually, is actually an angle. When we say to the power of -1, remember when we put anything x to the power of -1, in order to change that thing positive, we would have to write 1 over that thing. So to say that it's to the -1th power is not exactly accurate, which is why I keep saying arctan. And that's why Emmanuel keeps writing the arc of sine or the arc of cos, because technically it's not the inverse. It's not. It's how we find the angle. Okay, the angle of that. All right, does that answer your question, Tristan? I hope it does. Okay, can I give everybody 4 minutes to try question 14, 15, 16? I think we all kind of got an idea of where we're going with each of these questions. Can I give you guys some time? 4 minutes, peeps. Let's go for it. Actually, thank you. Yes. Narisha, thank you for reminding me here. This sweetie goes out to Emmanuel for doing the job, for doing the things. Well done, Emmanuel, for remembering. Two more minutes, everyone. 1 more minute. All right, folks, that's time. Let's have a look at some of these answers. Okay. All right. Please pop your answers in the chat if you're feeling like you've got this and you knew exactly what was happening, which I know most of you did, or all of you really. Okay, first, step number 1 is always to label. So we're going to start with number 14. That's my angle, so that becomes my opposite side. And that is my hypotenuse side. I'm going to skip some steps. Okay, I have my opposite and my hypotenuse, and I want my angle. So that's sine. Good. So we're going to go sine of theta is equal to opposite over hypotenuse. Then theta will equal to arc sine of the opposite, in this case, is 13 over the hypotenuse, which is 20. Okay. And we just need to put that into our calculator and get an answer. What do we get, peeps? Arc sine is of 13 over 20. Thank you very much, Fulani and Emmanuel. You guys are 100% on point. The answer we get over here is 4,54. Thank you, Emmanuel, for remembering. Another sweet for you, Emmanuel. Emmanuel's just raking them in today. Well done. Because Emmanuel remembered to say degrees. We're measuring for an angle. I feel like I'm going to give Emmanuel a sugar rush. Always, always, always with the sweets. Well done, dude. Well done. He remembered the degrees. Beautiful work. All right. Yeah, I bet you all have the same answer. Okay. I bet you all do. Because you guys know exactly, you guys know exactly what you're doing. All right, let's go on to question number 15. Again, we're going to label this as the adjacent side. That side is the opposite side. I'm not going to bother labeling anything else. Yes, it is to 2 decimals, my darling. So there, 54. The 40,54 degrees. I think maybe my handwriting is a little, sorry, it's 40,54. And yes, absolutely. Thank you, Theo. We're going to shift angle. Thank you very much. So we're going to get what we have is opposite and adjacent, and we want the angle again. So we're going to use tan. So we'll have tan of theta is equal to opposite over adjacent. Maybe let's write that a little better. Adjacent. So theta is going to equal to arc tan of opposite, which is 5 over 11. Therefore, our angle is equal to how much? 24,44 degrees. Well done. Yes, Desmarie. Yes, Princess. Absolutely. I saw somebody put a shout out to Tanjiro, and please don't get me started because I love Demon Slayer so much. And we need to focus on what's happening in class right now. So please don't take me on an anime spin right now. Okay, let's focus. All right, let's look at the next one over here, question 16. This part over here is adjacent, and this is our hypotenuse, right? So we know we have adjacent and hypotenuse. We want the angle, so we know we're going to have to use cos. Correct. I was just waiting for you, Kulani. I was waiting for you. Cos is equal to A over H. But because we're looking for the angle, we must shift angle. Good. So theta is equal to arc cos of 4 over 5. And that is equal to, what is our angle theta equal to here? 36,87 degrees. Oh, I'm loving all the degrees. We're all remembering. Okay, thumbs up. How are we feeling about finding sides and finding angles? Are we all okay with this idea? I don't think it's that difficult an idea at all. I think you guys have got it down pat. Some of you guys, I can even see some of you guys skipping the steps because I know that I keep going label, have verse want, you know, all that kind of stuff. Guys, Desmarie doesn't trust me. Yeah, Desmarie doesn't trust me. Every time I say something, she's like, it's nice for now because, ma'am, you always complicate life. I promise I'm going to complicate life, but it's going to be okay enough for us to do. I promise. Okay, if any of you guys want any more practice, I'm going to give you questions 17, 18, and 19, and 20. All right, so you can take a screenshot quickly of 17 and 18. Okay, I know. She's like, we're not there. If we need a little bit more practice, there's 17 and 18, take a screenshot. And then 19 and 20, take a screenshot. Let me see if I can make this a little bit smaller so you guys can see them all at the same time. Okay. All right, yeah, there we go. Okay, there's 17, 18, 19, 20. Okay. You can either take a screenshot or you can quickly do a rough sketch. I'm going to give everybody about a minute. Okay. Take a picture, take a screenshot, do what you got to do. Okay. All right. So let's look at something that would actually come out in an exam. It's an exam question, really. Okay. And I want to show you guys how they actually ask these trigonometry questions in an exam setting, because they don't really give you much, which is why I'm kind of trying to emphasize the idea that we need to know the steps. So this is what the question would actually look like. This is what the question would look like. The instruction would say, solve for X and Y. All right, that is the instruction. And if we look at the drawing we've been given, we need to first contextualize. We can't just decide, let's go, I got this. We need to really think about what exactly is happening over here. So we need to think through everything that we're seeing before we even think about picking up our pen and writing down an answer. So here is my first question before we go into this. How many triangles do I have? In this particular drawing, how many triangles are we looking at, peeps? Eric says 2. Fulani also says 2. Wiganyo also says 2. Emmanuel says 2, but Vukosi says 3. And I agree with Vukosi. I want everybody else to go find the third triangle. Good, Siketelo. There are 3 of them. Good. Sia's got it. Good, good. That's it, Emmanuel. Excellent. Are we all getting it? Right. There aren't just 2 triangles. There are actually 3. So absolutely we can see that this is one triangle, 100%. There is the other triangle. Correct. And that's it, Tristan. The outer layer of the other 2 triangles, this whole thing here, this is also a right angle triangle. That's why they've put that square over there to show us that there's another right angle triangle. And remember, we can only really do trigonometry, or we can only do SOHCAHTOA if we have a right angled triangle. So technically what we've got here are 3 triangles, right? So we know we can work in whichever 3 we want. So we want to lay this out for the examiner or for whoever's marking our paper as best as possible. So let's maybe say we want to start by solving for X. What is X? What is X? A what? Perfect, Princess. Beautiful work, Emmanuel. That's it, Eric. It's an angle. Beautiful. Good, it's an angle. So we already know we're going to have to click shift, right? So what we want to do now is we want to find the triangle of all 3 of these. which triangle has the most information? If we want to solve for x, which triangle would give us the most information? We have three triangles to work with. We can either work with triangle ABD. We can either use that big triangle ABD. But remember, if we use that one, we're going to run into a problem because I'm going to get 6 and y. Those are two unknowns. So that's not going to work. But I can see everybody's kind of seeing it. We need to work in triangle ABC. Who can tell me why? Why should we work in triangle ABC? Who's got an idea for me? Correct. We've got most of the information in that one triangle. The other two, not so much. They're lacking quite a bit. So we're going to start in the triangle that we can tell. So, good. Ziketel. Oh, wow. Sure. Beautiful. We're already off to a great start. So when we start answering the question, we're going to do this. We're going to say in triangle ABC. Beautiful. And we know that we need to find sine. So we're going to start by, or x, we need to start by labeling. I know that this side over here is the adjacent. That side over there is the opposite. And this is also a right angled triangle, which means that side over there is the hypotenuse. Both of them are. Okay, that one is labeled nice for us. Okay, good. Now I know I've got what I have right now is I've got the opposite and the hypotenuse, and well done, Khulani, absolutely. And we want the angle x. Okay, so we're going to use sine. So let's go ahead. We know sine of theta is equal to opposite over hypotenuse. Now we're just going to substitute. Remember, we're looking for the angle x. So we must click shift. So we know that x is going to equal to arc sine of the opposite, which is 4, over hypotenuse, which is 6. All right, give me an answer, peeps. What is the answer for x? Thank you very, very much, Emmanuel. 100% the correct answer, what I'm looking for. Good. 41,81 degrees. Good. 41,81 degrees. Beautiful. Good. And then as soon as we have something, we don't want to just leave it lying out of nowhere. We're going to take the answer we've been given and we're going to put it on our drawing. So now we can see exactly what we have. Great. We've now solved for x. Beautiful. How are we going to solve for y? I know that I could do this. I could use this triangle. Is that going to help me? Using triangle ACD, is that going to help me? Emmanuel says yes. Okay, let's think about it. Okay, we're solving for y. We know that y is a side. So first thing we need to do is what? What is step number 1? Narisha's like, isn't. Okay, Emmanuel, what is step number 1, guys? Step number 1 is to what? It's to label, correct. And if I'm going to label, what do I need? What do I need? What am I labeling in terms of? A what? An angle. Good, princess. Let's look at this particular triangle. Let's look at this particular triangle. Do I have an angle? No, I don't. I like how you're like, nah, ma'am, nah, no angle. No, we don't have an angle. So we cannot actually use the triangle ACD. Which triangle do we think we're going to have to use to find y? That's okay, Emmanuel, but it's not going to be able to, it's not going to work for us in this case. Actually, No, it won't work for us, unfortunately, even with Pythag. Correct. We need to look at the bigger triangle. We're going to look at triangle ABD. So we're going to go in triangle ABD. So we're going to use the big triangle, which is great because we can label. Do we have an angle that we can use to label? Yes, we can. We've just figured out what that angle is. Lucky for us, we've even put the angle in. Right. Here's my angle. Now, if I look at the big triangle, I know that the 6 over here is my adjacent side. That y over there is my opposite side. Yes, it is, Emmanuel. Look at what they've done over here in the corner. Do you see how they've given us a square there? What does that square in the corner mean? That's okay. That's okay. It takes a little bit of a while to see it. Okay, now all that tells us is that, yeah, BCD is the hypotenuse. Correct, Ziketelo. Oh, Sia, and similarity and congruency is coming back. It's coming back. It's there in grade 10, I'm sorry to say. All right, great. So now let's look at, we've labeled, which is great, but in this particular case, we're definitely going to have to do a have and want. It's not that easy to see without us having to go into a little bit more detail. Right, what do I have? Who can tell me what do I have here? I'm sorry, I'm sorry. Unfortunately, it's going to follow you all the way to matric. What do I have, guys? Tell me, according to my drawing, what do I have? Good. I have the adjacent side. Thank you, Siketelo. What else do I have? I've got the adjacent side and? Good. Beautiful. Kulani, we've got the angle. We found the angle. The angle was 41,81 degrees. We found the angle. Great. What do we want? Good. We want the opposite side. Good. So yes, Kulani, 100%, we're going to use tan. So let's go ahead and use tan here. We're going to get tan of theta is equal to opposite over adjacent. Right. Now all we have to do is substitute. I'm going to leave this part to you guys. I think I've taken you far enough. Find me an answer for why, please. I've taken you guys to the edge of the question. Now it's your job to jump over. Okay, give me an answer in the chat. Right, y equals something. Sure, Emmanuel, that was super quick. All right, let's see if you've got it. Let's wait for everyone else. Beautiful, nicely done, princess. 1 more minute, guys. It shouldn't take us that long. It's the end of the question. All right, peeps, let's have a look at the answer here. Okay, we're going to substitute here, right? I know I'm going to get tan of, I have my angle this time, so I'm not going to click shift. Tan of 41,81 degrees is equal to opposite, which is y, over adjacent, which is 6. And then we're going to put this over 1, and then we're just going to cross multiply. Cross, cross. So I know that 1 times y will give me y is equal to 6 times tan of 41,81 degrees. And if I punch that into my calculator, indeed, the answer I should get here is 5,37. And look at you guys, you managed to do an exam type trigonometry question. How are we feeling about this question? Yeah? Kind of okay. For now. For now, I think it's pretty okay. I think the questions aren't that difficult. I think there's still touch and go here and there, but let me see. This kind of question is worth solve for X and Y. This question is worth 6 marks. This is a 6-mark question in an exam. We were just here for moral support. Okay, all right. How about let's do this. Let me give you another challenge. Okay, how about I give you guys one for you guys to do on your own? No, we can't stay confused. We must do it. We must do it. All right, here's another challenge for you guys. All right, same idea. I want you guys to solve for X and Y for me. All right. Let me just get this right. Let's make sure. All right, this is fine. Okay, here's your next challenge. Okay, so it's along the same route, and we're only going to do cosec, sec, and cot on Wednesday, not today. A lot, Tristan. This is big school, so probably 100 and something marks. Okay, my bet is on 100, but we'll see how some teachers do. Okay, here's your next question, guys. I want you guys to solve for X and Y. I'm going to be quiet, okay? Remember, guys, just if we follow the 3 steps, step 1, step 2, step 3. Yeah, some of them do come up to 150 correct, Sia. Okay, all right, step 1, step 2, step 3, guys. I'm going to be nice enough to even add SOHCAHTOA on the side for you. There's no need because you guys should know SOHCAHTOA by yourselves. But, oh, on Wednesday, we're learning about the cousins of sine, cos, and tan. We're learning about the cousins. I'll tell you all about the cousins on Wednesday. Okay. For now, let's all use what we've got to solve for X and Y. The whole family, Vukosi, I'm going to introduce you to the whole family. The whole Trig family. All right, pop your favorite emoji in the chat when you're done. Okay, none of these should be difficult. Yes, yeah, you can't be the only one with cousins. Maths must also have cousins. All right, peeps, I don't think this one is that difficult. This one should be quite okay. Okay, there's another one that I want to leave you guys with. Okay, so let's quickly solve for this one. This one is easy. We're looking for 2 sides. They've already given us an angle. We should all be quite okay to do the things. One more minute. Wiganyo's already done. Having the time of her life already done with the questions. All right, peeps, let's look at the answers here. These are not that difficult. Okay, we'll start with labeling because labeling is going to help us for both X and Y. Right, 7 over here is our adjacent side. X is our opposite side and Y is our hypotenuse. Right, so we just need to start with the one that gives us the most information. We can start with X, we can start with Y, it's not going to make a difference. Right, I'm going to start with X. Okay, if I start with X, I know what I have is I've got an angle, 42 degrees, and I've got an adjacent side. And my want in terms of X is my opposite side. So I know I'm going to have to use tan. So I'm going to go tan of theta. Thank you, Emmanuel. Thank you, Kulani. Tan of theta is equal to opposite over adjacent. That says that tells me tan of 42 degrees is equal to opposite, which is X, over adjacent, which is 7. And then I just need to cross multiply. So multiply that way, multiply that way. 1 times X will give me X is equal to 7 times tan of 42 degrees. Right, and if I punch that into my calculator, thank you very much, Emmanuel, X is equal to 6,30. All right, beautifully done, nice work. Right, 6,30, that is X. Now, to find Y, there are 2 different ways that I can find Y. Because I have my opposite side, I know that my opposite is 6,30. Okay, I know that X is equal to 6,30. So when I want to solve, correct, Emmanuel, when I want to solve for Y, which is the hypotenuse, I could either use the opposite and the hypotenuse, or I could use the adjacent and the hypotenuse, or 100% Zigetelo. Remember where we started with trigonometry? It wasn't with Hipparchus. It was with Pythagoras. So you can use all 3 of those methods. You can either use sine, opposite over hypotenuse, cos, which is adjacent over hypotenuse, but because this is also a right-angled triangle and you've got the short side and the short side, you could use Pythag to find the hypotenuse. Okay, so you can do either of those things. My recommendation, however, is to always use the information that you have been given. Okay, the reason why I would say don't use the answer you got for X is because if you somehow, maybe by accident, pressed the wrong number on your calculator when you were calculating for X, okay, if you clicked the wrong number and you got an answer, we're still going to give you method marks, but your final number is going to be wrong. So what we'd rather do is use the information that we've actually been given. Okay, so in this case, because I've been given 42 and I've been given the adjacent side, I'm going to use the information that I've been given. So I'm going to use cos. I have the 42 degree angle and I have the adjacent side, and I want, in order to calculate for Y, I want the hypotenuse. Okay. So I'm going to use cos. I'm going to use cos of theta is equal to adjacent over hypotenuse. That tells me that cos of 42 is equal to adjacent, which is 7 over hypotenuse, which is Y. And then again, we're just going to cross multiply. Y will go over and 1 will go over there. Okay, so I'm going to end up with Y cos of 42 degrees is equal to 7. And because I want Y on its own, I'm going to divide both sides by cos of 42, cos of 42. All right, and those 2 will cancel. Therefore, Y is equal to, now I want you guys to note here, it doesn't matter whether you used Pythag, whether you used sine, or whether you used cos. You should get the same answer for all 3. All of them should give you 9,42 as an answer. And you can double check me on that one. You can 100% confirm. You'll see every single one of them will give us the exact same answer. All right. Let me drop this little nugget on the screen before we go. Okay, this is something I want us to look at in the next lesson. All right. All right, so this is the kind of question, let me see. Wish it was like physics where you can substitute incorrectly but they'll continue marking if you use the right method. We do, Emmanuel. That's why I'm saying, if you did this correctly, we're going to give you a method mark. It's just the answer will be wrong. So we'll give you a mark for using the correct method, but your mark for accuracy, we're going to have to take that away. Okay, so it's kind of the same. All right. Yeah, we do it exactly the same. All right, here is a challenge. You can screenshot this. I want you guys to try this one. Okay, we're going to start, yes, we're going to start with this question on Wednesday. Now, I want you guys to note again, I'm going to ask you guys again, when we look at questions like these, first thing we need to ask ourselves is, how many triangles are we working with? How many triangles are we working with here? Let's start there. Okay, have a look at it. Remember what they actually want from you. Tristan says 2, Emmanuel says 3. I agree with Emmanuel and Ziketelo and Vonaka. Okay, right. Now, the problem here is I can understand why Tristan says 2 triangles. Because if we're talking about trigonometry, what kind of triangles do we need? What kind of triangles do we need in order to work with trigonometry? Correct. Good, Tristan. The only triangles that have right-angled triangles are that one. That's one. And that one. Those two. Only those two. The third triangle, absolutely, we can see it. Here it is. There. It's a triangle. It just doesn't have a right angle. And it's going to be difficult for me to work with it if I don't know what to do with triangles that don't have right angles. Okay. Not quite. Not in this question, Buikanyo. This question is going to require you to do steps 1, 2, and 3. Okay. And remember, what the question wants from you is it wants you to solve for AB. We're solving for this little part over here. All right. So this is where we're going to stop for today.